Assalamualaikum and good day everyone. Now we will be solving exercise 2.4. We'll start with question A. Given in the question that P and Q will have a resultant R and this R is vertical. So we can sketch the direction of R. We know that vector P plus vector Q will give us a vertical R. Vector P is at an angle of 40 degrees with respect to horizontal axis, while vector Q is at an angle of 20 degrees with respect to vertical axis. We can deduce what the angle here, since the angle between horizontal and vertical axis is 90 degrees, angle here is 20 degrees, so the balance here will be 70 degrees. While here we have a 90 degrees triangle, the angle here is 40 degrees, so the remaining angle here must be 50 degrees. Hence, the angle here will be the angle within a triangle, 180 degrees, minus 70, minus 40, minus 50, which will give us 20 degrees. Since we have only three vectors here, P, Q, and R, we can use trigger approach to solve this problem. So I'm going to use sine rule. The aim here is to find the magnitude of force Q and R. We can write magnitude of force Q divided by the sine of angle opposing vector Q, in this case 50 degrees, will be equals to vector P divided by sine of angle opposing vector P, in this case 20 degrees. Substitute the values of P and rearranging, we can get vector Q is equals to 223.98 Newton. Next, we can calculate force R using the same approach, again using sine rule. Magnitude of vector R divided by sine of angle opposing vector R, in this case equals to 70 plus 40 degrees, will be equals to magnitude of force P divided by sine of angle opposing vector P, in this case 20 degrees. By substituting value of P and rearranging, we can get magnitude of vector R equals to 274.75 Newton. Next, we will solve question B. In this case, the direction of R is unknown. To guide our solution, we draw back force P, Q, and R. Vector P has an angle of 40 degrees with respect to horizontal axis. Vector Q has an angle of 20 degrees with respect to vertical axis. R must be starting where P starts and ends where Q ends. This is our vector R. The direction of R is unknown. Now we have to determine the angles within this triangle. The angle between horizontal and vertical axis is 90 degrees. So the angle here is equal to 90 degrees minus 20, which is 70 degrees. Since the angle here is 40 degrees, the angle here must be 40 degrees as well. The angle here is 20 degrees, while the angle inside here is equals to theta. The remaining angle here is beta, whereby beta is equals to 90 degrees minus 40 degrees minus theta. Once we have determined all the angle within this triangle, we can solve it using trigger approach. In this case, the most appropriate will be to use cosine rule. We will start off by determining the magnitude of R. We can write R squared equals to P squared plus Q squared minus 2 times PQ cos of angle opposing R, in this case 70 plus 40 degrees. We can use sine rule to get following equation. Magnitude of force P divided by sine of angle opposing vector P, in this case 20 degrees plus theta, should be equals to magnitude of force R divided by sine of angle opposing R, in this case 70 plus 40 degrees. Substitute the values that we know, we can get, thus theta can be given as, which is equals to 8.02 degrees. Once we know theta equals to 8.02 degrees, we can calculate beta, which is equals to 90 degrees minus 40 degrees minus 8.02 degrees, which is equals to 41.98 degrees. We will be using sine rule again to determine the magnitude of Q. Magnitude of Q divided by sine of angle opposing Q, in this case equals to beta, is equals to magnitude of vector R divided by sine of angle opposing R, which is equals to 70 plus 30 degrees. Substituting values that we know and rearranging, we will get Q equals to 142.26 Newton. Therefore, we have known the direction of vector R, which is at an angle of 8.02 degrees from vertical axis.